Hi everyone. Next application of the Gauss law is electric flux density due to infinite sheet of the charge. So consider an infinite sheet of uniform charge density rho s coulombs per meter is placed in z is equal to 0 plane, that is xy plane. Infinite sheet of the charge is placed in z is equal to 0 plane. Consider a rectangular box which is cut. Consider a rectangular box as a Gaussian surface. A rectangular box is a Gaussian surface which is cut to the infinite sheet of the charge. Infinite sheet of the charge. In the rectangular box, consider differential surface ds. Consider differential surface ds. And this is the point P. At that point P, consider differential surface ds. At that point P, the direction of the electric flux density is normal to the surface. And this is infinite surface sheet. In that infinite surface sheet, consider a rectangular box. That rectangular box is a Gaussian surface. How to consider that rectangular box? This is a rectangular box. Consider that rectangular box. Cut the sheet. So on the rectangular box, consider differential surface ds at point P. At that point P, the direction of the electric flux density is normal to the surface. Normal to the surface means perpendicular to surface. And this is top of the surface and this is bottom of the surface. And the top of the surface, unit vector an bar is plus az bar. So this is the top of the surface. That part is parallel to the z axis. And this is the rectangular box. That rectangular box cut the infinite sheet and this above the surface sheet that is parallel to the z axis. Okay? And top of the surface an bar is equal to az bar and bottom of the surface unit vector is minus an bar is equal to minus az bar. At point P, the direction of electric flux density is normal to the surface and for top of the surface and bottom of the surface below the xy plane, the direction of the electric flux density is also normal to the surface. That is minus an bar is equal to minus az bar. Minus an bar is equal to minus az bar. So using Gauss law, Q is equal to closed surface integral of d bar dot ds bar. So now we have the electric flux density can be evaluated into top of the surface and bottom of the surface and side of the surface. Rectangular box has a Gaussian surface. So the electric flux density can be estimated top of the rectangular box, bottom of the rectangular box and side of the rectangular box. Now here the electric flux density is varying normal to the surface. Normal to the surface means that is parallel to the z axis. Positive z axis and negative z axis. There is no electric flux density side of the rectangular box. The side surface integral of d bar dot ds bar is equal to 0. So for above the xy plane, for top of the surface, so electric flux density d bar is equal to dz into az bar. So what is the rectangular box? Rectangular box is a Gaussian surface. Because of that, in Cartesian coordinate system or rectangular coordinate system, the vector form of the electric flux density is d bar is equal to dx ax bar plus dy ay bar plus dz az bar. So now here the electric flux density is varying normal to the surface. Because of that, only az bar components are considered, ax bar components and ay bar components are neglected. Therefore, d bar is equal to dz into az bar for top of the surface or above the xy plane. And along that direction, the differential surface ds bar is dx dy into az bar. So now calculate d bar dot ds bar value. So d bar dot ds bar is equal dz az bar dot dx dy az bar. So we know that dot product of the same unit vectors is unity. Az bar dot az bar is 1. Remaining value is dz into dx into dy. And bottom of the surface, below the xy plane, the electric flux density d bar is equal dz into minus az bar. So along that direction, the differential surface ds bar is dx dy into minus az bar. So now calculate d bar dot ds bar value. D bar dot ds bar value is dz dx dy. Dot product of same unit vectors is unity. So that is equal, and applying all these conditions into equation 1, we get q is equal, charge q is equal top integral of d bar dot ds bar. So for the top of the surface, what is the value of d bar dot ds bar? Dz into z dx dy plus bottom integral. For bottom integral, what is the value of d bar dot ds bar? Dz z into dx dy. And side of the integral, there is no electric flux density. That surface integral becomes 0. So therefore, dz is constant, that is written before integral, top integral of dx dy plus dz is constant, that is written before integration, bottom integral of dx dy. So that is equal, the top integral of dx dy is the area, and bottom of dx dy is, that is also area, capital A. So dz into A plus dz into A, that is equal to dz A. Area is coming to the LHS side, charge by area is equal to dz. So according to definition of the surface charge density, what is the definition of the surface charge density? Total charge to the total surface area. Total charge to the total surface area is called as surface charge density. How to represent surface charge density symbolically? Rho s coulombs per meter square. So Q by A is surface charge density. Rho s is equal to dz. So that is equal, the component dz is equal rho s by 2. Substitute dz value into top of the surface and bottom of the surface of the electric flux density. So what is the top of the surface of the electric flux density? D bar is equal to dz into az bar. And for bottom of the surface, what is the electric flux density? D bar is equal minus dz into az bar. Substitute dz value into top of the surface expression and bottom of the surface expression. So we get the electric flux density d bar is equal rho s by 2 into az bar coulombs per meter square for above the xy plane or top of the surface. So next calculate electric field intensity. So we know that the relationship between electric field intensity and electric flux density, d bar is equal epsilon naught into E bar is equal d bar by epsilon naught. And substitute d bar value into that equation, so we get the electric field intensity E bar is equal rho s by 2 epsilon naught into az bar. So this is the equation of electric field intensity and electric flux density due to infinite sheet of the charge. Infinite sheet of the charge for above the xy plane or top of the surface. And similarly bottom of the surface, what is the value of the electric field intensity and electric flux density? D bar is equal, for bottom of the surface, what is the charge density? Minus rho s coulombs per meter square. Minus rho s by 2 into minus az bar. Minus into minus plus, for bottom of the surface, what is the electric flux density? Rho s by 2 into az bar. And electric field intensity is also rho s by 2 epsilon naught az bar.